We're going to practice solving systems with two variables one more time. So again, you can use elimination or substitution. I would use elimination and multiply your first equation by 2 to eliminate our x's. And when you do that, notice how 2 times 5 gives us 10. We also eliminate y's, but 0 does not equal 10 when you add up our two equations, so our answer will be no solution. So since we have conquered two variables, we're going to move on to 3.5, solving systems with three variables. And we're first going to start off with just talking about before, when our solution was an ordered pair, we only had x and y. But since we have x, y, and z this time, it will be called an ordered triple. That's the solution to our system. Again, notice how we have x, y, and z equal to some number. So the first method we're going to start with is elimination with three variables. Go ahead and read through the steps. And just like before, if you obtain a false equation, 0 equals 1, we'll have no solution. And if you obtain 0 equals 0, the system has infinitely many or all real solutions. Alright, so our first system, 4x plus 2y plus 3z equals 1. That's our first equation. Then we have 2x minus 3y plus 5z equals negative 14. And 6x minus y plus 4z equals negative 1. So we first start off with numbering our equations to keep them organized. So I'll number them 1, 2, and 3. And we need to pick two of them to add together to eliminate a variable. So I'm going to look at finding which variable easiest to eliminate. I'm going to choose 1 and 3, and we're going to eliminate y. Now, looking at 1 and 3, we have a 2y and a negative 1y. So I first need to bring down equation 1 because I don't have to multiply that by anything. So I'll have 4x plus 2y plus 3z equals 1. And then we have to multiply equation 3 by 2 in order to eliminate our y. So we multiply all these terms by 2. So we'll have 12x minus 2y plus 8z equals negative 2. Okay, same thing as before, we add up our two equations. So 4 plus 12 is 16x. Again, we're eliminating y, so 2 plus a negative 2, those are eliminated. And we add up our z's, we'll get 11z. And add up our constants, we get negative 1. Now, notice how we went from 3 variables to 2 variables, so I'm going to box this in, because we're going to use that later, and label it A. Next, we have to figure out 2 more equations to add up and eliminate y for. So I'm going to pick 2 and 3. We could have chosen 2 and 1, but again, 3 has that easy variable to eliminate. So since we're not going to be eliminating anything from equation 2, go ahead and rewrite that. So we have 2x minus 3y plus 5z equals negative 14. And we'll add to that equation 3, but again we have to eliminate our y here, so we need to get this to be positive 3, so I have to multiply all these by a negative, so we'll have negative 18x plus 3y minus 12z equals positive 3. Negative times negative is positive. Add up our two equations. And we get negative 16x. Our y's eliminate. And we'll have negative 7z equals negative 11. And this equation here will be b. Okay, so we went from 3 variables to 2 variables. Now we have to eliminate another variable by adding up equations a and b. Now it made it easy on us for this one because if you look, we have a positive 16x in a and a negative 16x in b, so all we have to do is add up those two equations. So when we add up our x's, negative 16 plus a negative 16 is gone. 11 plus a negative 7 is 4z. And that equals negative 1 plus negative 11 is negative 12. And now we're down to one variable. So we solve this out for z, and we get z equals negative 3. Now we have to solve for x and y. To solve for x, we can do that very simple by plugging it into either a or b. So we plug in negative 3 for our z here, and we should get x equals 2. And now that we have two of our variables, we have to plug it back into one of our original equations to find y. Doesn't matter which one you choose. And we should get y equals 1. So our ordered triple, remember your parentheses, will have 2, 1, negative 3. Again, it's just like an ordered pair, but since we have 3 variables this time, we're going to have an ordered triple. So we do the same concept. We're going to add up two of our equations. My suggestion would be to eliminate our y. So if you look at equations 1 and 3, if you number them again, easiest thing to do is number them. Keep them all organized. Again, this is just what I do. I like to keep stuff organized by labeling them. And if we add up equations 1 and 3, you don't have to multiply by anything. So x plus 3x is 4x. Our y's eliminate, and z plus 2z is 3z. And that equals 8. And then we have to add up two more equations to eliminate our y's. So we can do 2 and 3. But we're going to have to multiply our 3 equation by 4 to eliminate our y. When we do that and add them up, we get 16x plus 12z equals 27. And again, this was our a, and we added up our first two, and this is our b. So then we add up our equations a and b, eliminate another variable, so let's choose, doesn't matter which one, let's choose to eliminate x. So we'd have to multiply a by negative 4. So we have negative 16x minus 12z equals negative 32. And we add to that equation b, so 16x plus 12z that equals 27. And our last step is to add up our equations to eliminate our variables. So 16, negative 16 plus 16, gone. Negative 12 plus 12, gone. We're left with 0 equal to negative 5, which is not true, so our solution is no solution. Our next system, go ahead and add up equations 1 and 2, and you should get 2x plus 2y equals 8, which is your A equation. Then if we add up 2 and 3, we'll get 4x plus 4y equals 16, which is B. When you multiply equation A by 2, we'll get 4x plus 4y equals 16, and you add that to equation B. If you notice, all those terms are opposite signs of each other, so we get 0 equals 0, so our solution is infinitely many solutions. And we'll be working on this in class.